Welcome. You're listening to How I Did That, a storytelling podcast. Let's jump into today's episode.
First of all, thank you so much for joining me today. I'm very excited to have you on this episode and have a lot of questions on your journey in the chemicals industry, as well as how you became a professor and with QuantumQik Careers.
My name is Heinz Plaumann. Many students call me Dr. Plaumann. I have a PhD in chemistry and a master's degree in chemical engineering. And that came about through a strong interest in science of my older brother and I. He's got a master's degree in chemistry, spent over 30 years in the chemical industry. So we followed each other through school. My PhD is from the University of Waterloo in Ontario. His master's is from the University of Waterloo also. Following completion of my PhD, I went to work in industry for a number of years, and I wound up working in a research group and in a production unit supporting it as a chemist. And there was a recession in the early 1980s. I returned to school, took a leave of absence, and did a master's degree in chemical engineering. Returned to industry, worked at that company for a number of years. Business happens, that company was taken apart. I wound up working for a large German chemical conglomerate, BASF. I worked for them in Canada for a number of years. Then I worked in Germany for a number of years, then Charlotte, North Carolina, back to Germany for a few years, and then worked in Wyandotte, Michigan, outside of Detroit for about 15 before I retired. Much of that time I spent working in technical and business leadership roles, and also mentored a lot of my colleagues, just teaching them things like how to get ahead, how to plan a career, how to develop what's called a career roadmap. And I found that very, very rewarding to watch others grow to not just reach their potential, but exceed their own perceived potential. And at that time, I also started teaching part-time at Wayne State University in Detroit and University of Detroit Mercy. Interestingly, at Wayne State, I taught chemical engineering. At University of Detroit Mercy, I taught chemistry. I then retired from industry and continued doing that, but also started a company, QuantumQik Careers, through which I then run workshops on career planning, workshops on time effectiveness. And I also orchestrate for companies, for my clients, I orchestrate for them to move their culture in their organizations from good to great. So that's my elevator speech.
So when you graduated college, where did you go? Because you had a chemistry and math degree, right? So did you plan to work in the chemicals industry at that time with your chemistry math degree?
But I did not have my master's degree in chemical engineering until later. A PhD in chemistry, I guess I grew weary of being in school. If I had all the way up from grade school all the way through, I'd gone to school for almost 20 years. And I thought, gosh, I just want to get out and work, see what it's like to work for a living with a more structured schedule rather than, in grad school where you're just working you're like 24/7 on the call. So I went to work in industry. I did not want to pursue an academic career, for a number of reasons that became clear to me later, one of which is this: in an industrial environment where I spent over 30 years, problems are brought to you, challenging you by customers, by technical, growth in society. People want problems to be solved. And that is a very different challenge than the world of an academic. In that case, a professor has an idea, has some approaches to it, uses that to write grant proposals, gets the money, does the work, publishes paper, and starts over again in that cycle. So basically, you're creating your own problems, defining your own problems for you to solve, already having ideas to do so. In an industrial setting, you may not have any idea how to solve the problem. Very different challenge. And part of the benefits of having a problem defined in such a way is that you are counting on the experience and know-how of others. Whereas many professors, academics, in all their intelligence, tremendous intelligence that is captured, there's no question. It's, here's something that I already know how to do, and so I'm going to pursue that in this way. Whereas in an industrial environment, you say, I do not know how to do that. I need to draw on the experience and wisdom of others. That begets teamwork. And in industry, no one works alone. It's always on the basis of teamwork. Then you run into the challenge of different personality styles, different personality preferences, and just setting goals that the team has to meet.
I was going back to when you were graduating from your undergraduate degree, right? That was in chemistry and math?
Yes, I will tell you what happened there. This was in the mid 70s during the first oil crisis, and there were no jobs for chemists. Basically, there were basically no jobs for chemists at all. Colleagues of mine that graduated with their bachelor's degrees, they were going to work in banks, and I said, "Gosh, we suffered through Orgo and phys chem and stuff, so you could go and be a bank teller." And they said, "Look, I have to eat." I was fortunate enough to get a significant scholarship to the National Research Council of Canada, an NSERC scholarship, and continue to go to school. I said, school is not that bad compared to working in a bank. Nothing wrong with working in a bank, not my passion, not for me. One of my kids worked in a bank, and I admire her for that. But there was an economic downturn in the early 1980s. Yeah, the employer for whom I worked, they said, we don't want to lay anybody off. We would rather look at that in different ways. Does anyone want to leave of absence? And a few people took leaves of absence for other purposes. I took a leave of absence, went back to school, and did a degree in chemical engineering. So I was out of chemistry background, went back in school.
You went back to school and you automatically went into a PhD, but why didn't you do the master's first? What was the reasoning behind that?
Well, at the University of Waterloo, what happened was this. When I finished my bachelor's degree, I entered graduate school. If you did well enough in the first year of your master's degree, you could roll automatically into a PhD, and they accepted your master's credits as part of your PhD curriculum. And so I thought, well, it just happened, and my PhD advisor and my advisory board said, hey, you're doing well. We think you're smart enough to complete a PhD. Why not do that? Don't stop. Don't take this interruption of having to write a master's degree and a master's thesis. So just continue with the PhD. So yes, I've been quizzed about that a few times. Gosh, you have a PhD and it came before your master's degree. One's in chemistry. The master's was chemical engineering came later.
During that PhD, what exactly do you do in 5 years? Because that's half a decade. It's a very long time. Can you talk a bit about the highlights of a PhD? Like, what do you do? Your dissertation, for example?
I will tell you. Well, actually, my PhD took only 3 years, unusual. What I studied was organic synthesis of natural products. So my supervisor, my PhD supervisor, identified he had a long history and depth of experience in natural product chemistry. He said, here are some target molecules. What would it take for us to make these natural products synthetically in the lab? And so we designed synthetic schemes for those and pursued, and then it was me grinding in the lab to get it done. And the first 2 years went very well for me. Actually, there were some stumbling blocks in the syntheses, but they went okay. The courses went very well, so I could roll into the PhD program immediately. And then as we drew closer to the synthetic target, it's called the target molecule, everything crashed. It just did not work at all, didn't work at all. And I was actually considering just quitting school, leaving school, writing up a master's, getting out of school. And then, of course, I brainstormed with my supervisor, and he said, there's a side reaction taking place here. Let's figure out what it is. We did. And that led us to a completely different set of structures. That led us to a completely different set of target molecules we had not considered before. So within a matter of 2 months, we synthesized 7 natural products.
Wow, just because you decided to keep going and figure out what that side reaction was rather than quitting.
The side reaction, a total surprise until, well, it was a surprise, right? We paid attention and said, gosh, what's really going on here? Once we understood that, we said, oh, that takes us to a completely different molecular structure, molecular framework, totally different class of molecules. So anyways, so that became one of those serendipity follows those with their eyes open. Good luck too. So we had our eyes open. So I managed to finish my PhD in 3 years instead of the normal 4 or 5.
Oh, wow.
And I went immediately into industry. As I said, I was considering leaving school with a master's degree. At that time, I was already interviewing for jobs, received a job offer. And then once I turned that master's interruption into a full PhD, my employer said, well, we need you to start. I had to delay that, and they approved my delay of starting work by 6 months or so. And they said, fine, now you're coming with a PhD. You can go ahead, keep your job.
Oh, so after you graduated your PhD, you already had that job offer in hand.
The job offer was in hand, and I had to delay. They wanted me to start in May. I said, hey, can you do it? Because I've turned my master's pursuit into a PhD. They said, that's nice for us, nice for you, but we need somebody here to do the work. How long is the delay? And I said, well, end of the summer, end of August would be okay. And they said, back and forth, we discussed, and finally I started at the beginning of October of 1970.
Oh, I see.
Yeah.
Oh, that's awesome. But when you were during your PhD, those 7 natural products that you had synthesized. Can you talk a bit more on that? And were they published? Did all of your things?
Yeah, we have, oh gosh, I don't know. That would have been like the first. I think that publication was all wrapped up in one publication saying synthesis of this class of materials. I have, altogether I have, I know, 25. There were natural products that were identified from plants. One of them was known in Asia as a fish toxin to go ahead and control fish population. There was another one closely related to something that was a cancer reducing agent that I did not synthesize the full molecule. My boss himself, imagine this is now a PhD supervisor, a full professor going in the lab and doing the synthesis from beginning to end in the lab. He did that, published a paper by himself. Photophyllotoxin is the name of that compound. That's irrelevant, but nonetheless. And then some variations on those. So they were products that had been identified, extracted, and identified by previous workers. And here's a target. We've got this framework already, this molecular framework. We can use that. Let's go ahead and synthesize molecules around. So.
I was just curious what the motivation was behind choosing these specific things to synthesize, but like your professor, your advisor had already chosen these in advance.
No, he had, I'll say yes and no. It was in an area, because of that accidental discovery of that side reaction, that took him to a completely different, he had never synthesized compounds in that family before. Okay. Normally he was synthesizing what are called alkaloids. These are amine and nitrogen containing compounds that are medicinal in nature. Once we discovered that side reaction, we said, that takes us to a completely different class of molecules. And they have very different properties. So they're medicinal in nature too, but as I said, he just changed gears completely. Flexible, showed how flexible he was. And again, there's an academic side to that, which is the role just publish papers, right? Crank out some papers. I'll admit that.
I'm curious, like after you published these, did you ever hear about these molecules being used? Like, my paper is being used in this.
Yeah. Was there a practical use to what we published?
Yeah.
Not directly. Some subsequent PhD students, they had applications for the derivations that they worked on.
Right. So, okay. Yeah. And I guess maybe because you guys always work on very, very specific things, right? By the time you're doing a dissertation.
Yes. Yeah. The ones that I had, they were not directly identified as of high practical utility to humanity. I'll put it that way. But some of those, once we had that methodology, that synthetic methodology in hand, then subsequent PhD students, they identified different targets. They said, look, here's a target molecule. If we make this has these benefits to humanity. So we just laid some groundwork and then said, okay, here's a tool. How would you like to use it? Here's a certain kind of hammer. Go build that house. This is a different hammer. Go do some work on an auto body. So we identified a tool that then became the vehicle for others to go ahead and synthesize other molecules.
I see. And that's important too, because you can't get anywhere without using existing research a lot of the times, right? So you need someone to make that framework. So then after you graduated, you had that job offer ready. Where did you go and work?
It was for a company that at that time, they were one of Canada's top chemical companies. In fact, they were in the top 20 chemical companies in the world at the time. Polystar was the name of the company. Business happens. They were taken over later and taken apart. I was a research chemist for the first few years, working on cis polybutadiene. It's a rubber that goes into tire building. I worked in R&D first. Then the production folks producing that product, they said, you can talk to us, you speak to us in a very different way than most chemists do. Most chemists come here and they try to outsmart us with all their chemical know-how. You come here and talk to us in a way that we can understand. It was, I don't want to say I dumbed it down because engineers know a ton of stuff that chemists don't know, but chemists know different stuff. So somehow I was, I guess, lucky enough that I could bring it to the engineers so they could understand. They said, we want you to come work with us. So I was invited to take a job in production. And this is when the time, so I was surrounded by chemical engineers and they're talking about heat transfer and mass transfer and kinetics and totally different things that are somewhat foreign to chemists. So then, this is when this recession happened and I was lucky enough to get a leave of absence for a year and go back to school, do a master's degree in chemical engineering. And then, of course, I learned all the things around kinetics and process control and heat transfer and mass transfer. I learned those things. Came back after the leave of absence and started working at the same company, but they were then reorganizing, and I wound up working in a corporate R&D group, and that's when I got my first management job. And I found management was a very different can of worms. Wonderful experience. As I said, I spent most of my adult life working in leadership roles. The difference in managing a group or being, I'll say, a strong technical contributor is, in being a strong technical contributor, it's your expertise that gets the gold, I'll say. It's your expertise. In management, as a leader, it's other people's expertise. You become an enabler. And so for me, the biggest thing that I got joy from was watching my other people grow into their jobs and contribute well to the success of the company. Because in industry, it's pretty well all about the money.
Right, right. Oh, so was it Polystar, the name of the company that you were working at?
Yes, that was the name of the company. I have well, we're doing video, but this was their logo.
Oh,
I took this off of my lab coat. The company it was such a successful company that they became the target of a hostile takeover by a company in Calgary, Canada, in Alberta, named Nova. And Nova Chemicals took them over and basically took them apart. They sold one division to BASF. They sold their emulsion polymers group, the latex group, to BASF. They sold their rubber division to Bayer, which then became Lanxess. Bayer, also a German company. And that's now, Lanxess is the name of the rubber division that Bayer has. I wound up working for the BASF portion of the company. Mm-hmm. And then I had the good opportunity of moving to Germany for 3 years, and then moved to North Carolina, and then back to Germany, and then worked in Wyandotte, Michigan, outside of Detroit for 15 years for them.
What did Polystar originally manufacture, and what division were you working in when you first graduated your PhD?
They were, at that time, the world's largest producer of synthetic rubber. In an unusual way, they did not make any finished consumer products. So there was nothing that you could buy as a consumer directly from Polystar. But if you bought a tire from Goodyear, Michelin, Bridgestone, or Firestone, it probably had Polystar rubber in it. Now, a tire has a whole host of different things in it. And I'm going to show you something else. This is a slice of a tire. You can see from the side. You can even see it's got a cut in the side of it here. Now, this doesn't help you with your video, but this is a slice of a tire. This has got 5 chemically distinct elastomers. The tread here is made out of cis-polybutadiene. What's called the carcass, the main body around the sides is made out of styrene butadiene rubber. The sidewalls are made out of ethylene propylene diene polymers, because that is highly ozone resistant. The inner part, what's called the inner liner, what you used to have as inner tubes, you still have those in your bicycle, is butyl rubber or chlorobutyl rubber, because that is air impermeable. So each polymer, each of those has its own production technology. Now, so I supported first the cis-polybutadiene business, and then I went and supported some of the other ones.
When you got moved to production, was it? And that was when you decided to go back to school for chemical engineering?
Yeah. Okay. I was working in cis-polybutadiene production support. So I had some pilot things that ran in the plant and had some success with new products and things like that worked in. Now, just as an engineer, making butyl rubber has some, I'll say, some engineering wonders in it. The polymerization of isobutylene it takes place at minus 100 degrees Celsius. Minus 100, are you kidding? If you go higher temperatures, the polymerization kinetics is such that you don't get a high enough molecular weight. Then it becomes an adhesive, a sticky material, rather than a rubber. And so what happens there is chain transfer. The chain transfer reaction happens too fast, and you end up with a low molecular weight material. How do you get minus 100 degrees? Liquid ethylene. How do you get liquid ethylene? Liquid ammonia. So it's a whole sequence of cooling steps to get down to minus 100. Anyways, so that's what I did. And then I moved to a different group. That was when I worked in cis-polybutadiene. Mm-hmm. I then worked in an emulsion polymer, a styrene butadiene production support unit for a number of years. Then I moved back to corporate research, where we were doing research on some modified elastomers. And then the acquisition took place, and I wound up working in latex, so emulsion polymers at BASF.
Interesting. And so all of this, but in between all of this, you had gone back to school, like part-time while you were working?
Yes. I took as many courses as I could. So I had to take some core courses just to be, I guess, to be conversant in engineering. So I had to take process control and heat transfer, mass transfer, fluid mechanics, reaction kinetics, and I think there was one more that I had to take. But I had to take like 5 or 6 core courses just to enable entry into the master's program. But once I was there, I was already taking master's courses at school, and then through night school, I finished the course. I had like an industrial project where we measured a residence time distribution in part of a production unit, full-scale production unit, and we measured, people had suspected for years that the mixing in some tanks was very poor. So we did a residence time distribution. It was a 2-phase system. The first tank, they took a latex, so an emulsion polymer system, and they coagulated the latex. And then we got rubber formed in the first vessel. That was then filtered off in another step. But we have 2 phases going through the process. So I selected a phase selective tracer for the water phase and for the rubber phase. And then we did a residence time distribution by monitoring the concentration of the tracer at each vessel, each step in the process. And then I had to model that with Laplace transforms. Oh my God.
Wow.
All stuff I couldn't do now. I couldn't do any of it now. I've forgotten it all.
I was going to ask what the transition was like, because you didn't have an engineering background when you went into chemical engineering, and that was a master's too, right? But like you said, you did have to do a couple courses before you got in, and then everything.
Yes.
What you were saying with the tracers, was that your project in your master's?
That became my industrially relevant master's project, like a thesis, akin to a thesis. It's hardbound and it's 200 pages or something like that.
And then when did you go to Germany?
That was after the demise of that company, Polysar, taken apart. I wound up working for Polysar as a project manager first, and then after I did that for BASF for 3 years, and they said, well, we've got this program, we'd like you to train to take a more senior management role. Trained in Germany for 3 years, so we moved to my family and we moved to Germany for 3 years. I then returned to North America, but that group from Canada, from Sarnia, Ontario, had to move to Charlotte, North Carolina. So my next assignment was in Charlotte, North Carolina. I was the technology director for that business unit, for the emulsion polymers business unit. So I had an R&D group of about 60 people. I had a few managers in between. So people that reported directly to me, there was about 35 or 40 people. I was also the site manager for the Charlotte Technical Center. I think at that time we had about 150 people. So.
Okay. When you say emulsion polymers, can you expand a bit more on that? Because where can they be used exactly?
The most popular use for an emulsion polymer is paint, latex paint.
Okay.
Now, we did not produce the latex chemistry for paint yet. BASF now is among the world leaders in that for sure. But at that time, we were doing work that went into pressure-sensitive adhesives, carpet backing, paper coating. If you take a look at a glossy paper, that's actually coated with the latex. And so those are other applications. A large application also for the emulsion polymers that we made is asphalt modification. Because right now, and still, the best asphalt on the road for road construction comes out of Venezuela, if you can get oil out of Venezuela right now. Because asphalt, natural asphalt that's of lower quality, suffers from 2 problems. One is it gets brittle when it's cold, it starts to crack and break, and anyone that lives in Michigan knows about roads.
Mm-hmm.
And the other one is when it gets hot under load, like heavy transport trucks, it starts to float, then you get ruts. So it either cracks when it gets cold, or you get rutting when it gets warm. And by putting polymers in it, like latex or other polymers in it, you can overcome both of those problems. So those are some of the main applications for those types of latex polymers that we worked on.
And were those some of your main customers, like companies that needed it for these applications?
Yes, yes.
You were working on emulsion polymers, just to clarify, was this in North Carolina as well as in Germany?
Yes, yes.
Oh, okay. And can you talk a bit about German engineering culture compared to here? Because I've heard that there are quite a few differences. And I remember once you had mentioned in class, there was one thing you mentioned where like they're very, very strict on the time, and we're a bit more lenient here. But I'm just wondering, like, if someone like me were to go there, what do you think would be some of the biggest differences in engineering culture?
And these are wonderful things of this global culture. Every culture has its own quirks, let's say. And I've given talks on culture. One of the things in culture is we tend, when we see a different cultural behavior, we say, well, why did they do that? Why did they do that in Canada? Why did they do that in Germany? Or why did they do that in France? I suggest to people to ask the question, rather than why do they do it, ask why does it work for them? Because every culture only does what works. So in the German culture, just the way it's been for centuries is that being on time is the right thing to do. There's a thing around precision, doing the right thing. An example, in a German bank, there's a little yellow line on the floor and people line up, I'll say like soldiers behind the yellow line. They just line up, that's the right thing to do. If you go to some other cultures, like perhaps French culture or Italian culture, people just kind of storm the desk and it's okay. Everybody gets served and nobody gets hurt. But they don't want a yellow line. That's not in their culture. Their culture is a friendlier, more open culture. Mm-hmm. South America is much like that. In the United States, it's different. In Canada, it's different too. So if you are working in Germany, I've seen people just about jump over desks to be in a meeting room at 8 o'clock or at 7:59 because the meeting starts at 8. Because we are on time. It's just the right thing to do. It's the respectful thing to do. I preach that a little bit as rules. That's rule 1, be on time. Then it's a matter of being sensitive. Now, if you talk to people from, say, South American culture or Mediterranean cultures, Middle Eastern cultures, simply say, hey, what's your hurry? It's okay. So if you talk to, say, in some Asian cultures, it's a, hey, we're going to smoke cigarettes all day. We're going to smoke all day and then start the meeting tomorrow. Right? So then it's a matter of being sensitive to that. And as a North American, if I come in and bang on the table and say, hey, this meeting needs to start at 8 o'clock, I would be laughed out. I will basically unfriend the other participants. I'll say, well, who's this guy from North America?
Yeah.
It doesn't work. So that's a matter of being sensitive to the needs of other people. There's a suggestion I would have for anyone that lives in a foreign country is learn the language. Do the absolute best to learn the language because the culture is buried in the language, in my mind. The culture is buried in the language. And that's where I really learned that I was in the culture. If somebody told a joke and I laughed at the right point, that means I really understood it. So that's like a 95% integrated. I felt like 100% integrated. If I told a joke and they laughed at the right time. That's the worst thing that can happen is somebody tells a joke and you burst out laughing too early or too late, whatever it is. Or if you tell a joke and they don't get it. So you know fully that it's almost like a culture test. Am I in or am I not? A thing, because humor is always a quirk and twist on the culture and on the language. Mm-hmm. So I would suggest to anyone, a very good friend of mine has visited probably 50 countries and he's worked in them, but hasn't learned the language and actually lived there in India. And I challenged him on that. I said, you know, you tell stories about working in Brazil and working in Belgium and stuff like that, but you didn't really get in there with the language. And so he missed a large part of the experience.
Right. You're right. There's a lot buried in the language, which, like jokes, for example, or just the way you say things, it can mean something completely different if you're saying it in a different context or in a different language. When you were working there, did you know German like fluently, or like is your background German?
I will say I knew enough to be dangerous. My parents immigrated to Canada after World War II, and German was basically my mother tongue. I heard German before I was born. I heard German before I was born. So German was my first language, but then, and gosh, by the time I needed it again, 20 years had passed, so I'd forgotten so much of it. But it came back slowly as I started integrating into a company like BASF, where German was widely used. Once we moved there, then I had to really learn it again. But I learned a very colloquial and informal German. And in fact, after I worked there for a year, they said, well, you need German lessons because you're pretty good at it, but there's a lot of formality you don't know. You make a lot of mistakes, Heinz, and you could be much, much better if we give you lessons. So they gave me lessons. Interesting, my German teacher was from Egypt. I had to laugh when she introduced herself and said, hi, this is who I am. And I said, well, are you from Germany? And she said, no, I'm from Egypt. My husband's a German. Anyways, but it's interesting, again, there's so much captured in there. And as you know, words have so much meaning. They have so much feeling in them, even in English. There are words in German that when I say them, I can hear my parents saying them, and it had a feeling that I didn't know was buried in the definition. Over time, it became, I cannot say perfect, but it became very near perfect. The first time we lived there, People picked up right away. They said, well, you have an American accent. And I corrected them somewhat and said, well, I'm actually from Canada. They said, we don't care. You're from over there. So I had an accent. The second time I was there, I had, I guess, been so blessed enough that I learned German so well and spoke German so well that people asked me, where are you from in Germany? Oh, wow, what a compliment that was.
That's a compliment, yeah. So, and you went back to Germany, so you lived there twice in between living in North Carolina.
Yes.
Right. Do you think that if in BASF, because it's an international company, do they just fully speak German, or are there people from Canada or America who just speak English?
Oh, there are lots of people who speak only English.
Oh.
Many people. Many people speak only English, and they do well. They do very well within the company, but there are also many people that I know that have had international assignments. And if there is a willingness to adapt, part of which is learning the language, then they do very well fitting into. Sometimes there are some people that say, well, I don't need to learn that. Everyone globally has some kind of operating skills in English. And I've seen this happen. People that were assigned to work in Germany, they came from North America, and they just said, I don't need to learn German. Everybody understands English. They missed a large part of the experience. And in some ways, they alienated themselves from their coworkers. It came across as being somewhat arrogant, saying, I don't need to accommodate you. You need to accommodate me.
That's true, because if you're in the country that you're working in, people kind of expect you to take an interest to learn the language because you moved there, right, to work there. So, you were working at BASF, and how long did you stay there for? And were you always in the emulsion polymers area?
So I worked in the emulsion polymers 3 years in Canada, 3 years in Germany, and about 5 years in North Carolina. So roughly a decade in the same business unit, doing the same kind of jobs. Then I received an offer to move back to Germany to switch business units and work in urethanes. And then I moved back to Germany, to a different part of Germany. And this itself was an interesting experience. The first time we lived there, we lived in former West Germany. The second time, former East Germany, between Dresden and Berlin. And very different culture. There were still a lot of, I'll say, remnants of the Soviet era, of a lot of, I'll say, political and economic oppression. Very different culture. And then I was a manager in polyurethanes of a group there. I did that position for 3 years. Then I moved to Wyandotte to Michigan and headed up the urethanes R&D group here for 5 years. Then I moved to detergents and surfactants, which is, again, a totally different chemistry and totally different world. And then I went back to urethanes for a few years before I retired.
For urethanes and then surfactants, can you talk a bit about their applications?
Polyurethanes, they are all over the place. I can show you many samples of things here in my office. It goes into things like foam. For example, the seat in your car is made of polyurethane foam. The instrument panel itself may be a urethane skin. Urethanes are used in shoe soles. They are used in coatings. They are used in many applications. Surfactants, of course, cleaning stuff. So anything that you have in your kitchen that cleans, anything that you can do other things with, you can use surfactants in making polymers as lubricants. For example, emulsion polymers, the emulsions are generated by using surfactants. So they are widely used. Surfactants are used in flame retardants. They are used in flame suppressing agents and a whole host of things. So widely used again. So one of the most interesting things I found in my career, and I've been so blessed in this, I can't go anywhere without touching everything. I sit in my car and say, oh, this is a urethane seat. This is a urethane coated steering wheel. Oh, this is a urethane cushion. I go into a grocery store. Oh, look at all the surfactants. Look at all the cleaning stuff. Yeah, it just reminds me, yep, I've worked in this area.
Yeah. Which area did you like the best?
I would say that the reward in working is around the people within my work. I so liked working in the surfactants business, the soap and detergents area, because the people around me so supported me, and I got such pleasure supporting them in their successes. Some of those people are still some of my best friends. There's a particular person there that I've created some really neat positions for him, and he grew into some really nice leadership positions. And now we say we mentor each other. He mentors me now. And he just retired about 6 months ago from the industry.
Didn't BASF have a large chemical explosion at one point?
Oh, they did. Well, they've had several. They had one in the, I want to say in the mid 1930s or something. They basically wiped out a town. huge crater resulted from that. But this is when they were still developing very, very new technology. But like a chemical plant, I don't want to say you take big risks, but you take measured risks. They've had fatalities. They've had people exposed to phosgene, and people died from that. They've had other explosions. They had a large explosion at a Heinz Plaumann plant I think it was a pilot plant in the Cincinnati area, around 1990 or so. And yeah, there were fatalities there. Exposures to chemicals, it's a risky business. Of course, I would not say they take risks. Everything that they do takes measured risks, and the idea is to minimize all those risks. Because there are no small incidents in the chemical industry. Everything is a major incident. An incident is usually called an OSHA recordable incident. OSHA stands for the Occupational Health and Safety Association. We would estimate that an OSHA recordable incident would cost about $20,000 to $40,000. You've got lost production, you may have injuries, and that results in lost time off work, etc. So there's no small deal with safety. It's always a big deal.
There was one case I remember from class where I guess the material in one of the pipes is not BASF, but the material that the pipe was made of, I guess, didn't hold up when the temperatures got really, really cold, and they hadn't accounted for it, and then it cracked. And then the material that leaked through the pipe interacted with the air and basically bust everything up.
Oh, I think was that one of the projects that was presented?
I just remember that it was just such a small thing that caused a lot of fatalities or caused everything to explode. And it was like chemical safety is really important. So that was an interesting class. But I realized that I overlooked so many things when we were trying to analyze all the different ways that we could make a plant safe, or make a chemical process safe. So there are so many things that even with people working together, you may overlook. And we saw that in fatalities and explosions.
Yeah. Again, I would say that you're right. It's a risky business, but it is so deeply, I don't want to say investigated. Any incident is very, very deeply investigated. Mm-hmm. They will, I'll say, endlessly explore what are called the 5 whys. Why did this happen? Why did this happen? Why did this part of it happen? Why did this happen? What happened next? But before preventive measures are so intensely studied and put in place, because again, there's nothing cheap. It's all about the money. If you have an incident and you lose $40,000, for example, because of an injury or something like that, first of all, we want everyone to go home safe. Go home the way that you came to work, safe, all fingers intact, seeing everything like that. We don't want any fatalities. I don't remember that particular case. I think it might have been in a project, but yeah, there are things like that we can't see everything. And then when an incident happens, then there's this investigation, as I said, that takes place and says, why did this happen? And they use a rule of thumb called the 5 whys. Mm-hmm. Why did this happen? Why did that lead to that? Why did that lead to that? Why did that lead to that?
After you finished at BASF, where did you go from there? And what year was that in? Like your last year there?
5 years ago. 5 years ago already. I was already teaching part-time at Wayne State. And I'm very thankful to Dr. Chuck Mankey, he was the chair of chemical engineering at the time. Mm-hmm. Through connections, he said, well, I've got this course. Would you like to teach experimental design? I said, I'm a super fan and user of it. I would love to teach that. So I started teaching that already long before I retired. So I've been teaching that course. I'm not teaching it this coming semester, but I taught that course, I want to say, a better part of a decade. So I was already involved in the Industrial Advisory Committee at Wayne State for chemical engineering, industrial rep on that. And then when I retired, I kept teaching at Wayne State. And then I created this company named QuantumQik Careers, where we do, as a business, we do career mentoring with people. We do time effectiveness lunch and learns. I'll say lunch and learns are one of the gigs that we do, but it's all around time effectiveness. And then we also do, I'll say, corporate cultural analysis. We want to move companies from good to great, per Jim Collins' book, Good to Great. And what we need to do is understand first, where are we? Where are we? And what do we need to do to become great? What does greatness look like? And as he says in his book, one of the biggest obstacles to becoming great is being good. Even in our vernacular, we say, oh, I'm good, implying I'm good enough. No. We need to change those paradigms to become better. I need to drop some of the things I'm doing now to become better. But we've always done it this way, but not anymore. And that's where this catastrophic pandemic that we're going through right now has that opportunity. Like all the old rules have changed, right? All the rules have changed.
Mm-hmm.
So we can no longer hide behind that and say, well, we've always done it this way. But now we're doing it different. Now you might as well do it the best way or better.
How did you get on the advisory board of Wayne State to begin with? Was it just through connections?
Connections, yep, just connections.
And then
My predecessor on the advisory board was a guy named Bob Wickman. Bob was the manager of the analytical group, and then he said, well, he had done it for a number of years and said, I want somebody else to do it. And I don't recall the sequence whether I was starting to teach already or whether I joined the advisory board, but it's irrelevant which one came first. But he connected me then with Chuck, and discussion with Chuck, I'll say an interview lunch or something like that. He said, yeah, Heinz, you'd be good for it. So, I chaired the industrial advisory board for, 6 or 7 years. After the first 3 years looking for a replacement, couldn't recruit anybody because it worked. Finally, I found someone else. His name is Tony Makovsky. He's a quite expert in water treatment chemistry for Nalco. And so he's taken over the advisory board, but I still consult with him.
what's your role as a member of the advisory board?
I make trouble. I'm always asking things. One of the biggest things, and I put this on as a project, I call it a curriculum development project. I think Wayne State does a really good job of equipping students and chemical engineers academically. Here's the stuff you need to know. You need to know Fuller's kinetics. You need to know the safety textbook. You need to know those things. But that's not all that's required to do well in industry. To do well in industry, there are many other skills. And people call them soft. I don't call them soft. They're not soft. They're essential skills around time planning, around communication, around understanding, around listening, around project planning. Those kinds of things, they are so essential to do well in industry. And so I put together a project that I called Enhanced Career Preparedness. And I proposed it to the Dean of Engineering, and it floundered a bit, and didn't really go anywhere yet. It's still actively being pursued. And one of the things that I've done in the past year is I've connected through people like yourself, to my former students who are working in this. I say, well, can you connect me with your human resources person at, say, Plastic Omnium, at Ford, at L&L Plastics, at GM? Can you connect me with these people so I can talk to them and ask them straight out that question? What do we need to do in a university to prepare our students better? I wrote an email today to somebody to the HR person at American Axle, because they employ a lot of Wayne State grads, mostly mechanical engineering. What do we need to do to make sure our students are not just engineering ready, but industry ready? Because industry is not school.
Oh, that's true.
School of source, you're learning stuff. I tell people, don't be a know-it-all, be a learn-it-all. Once you get there, what you knew in the textbook, it's old, it's relevant, but it's not the problems you're going to face.
Right. And that's very true, because during undergrad, I did feel that there were a lot of classes geared towards, the fluids, the thermodynamics, kinetics, all of that. We had some technical writing classes. We had a lot of presentations in labs, but I still found that even when I was graduating, there were a large number of our a large portion, I'd say, of our graduating class, we were still told that we were not the best technical writers. And we get told this even after we graduate. I hear it from other people where, engineering graduates, entry-level graduates are not very good technical communicators. And I don't know what we could do to better that, but you had mentioned that you had that enhanced career planning. What was it called?
Enhanced career preparedness as a proposal, as a curriculum proposal.
And so with that, to change the curriculum to incorporate students, to integrate that. Okay. What changes did you make to the curriculum? I'm just curious what you would want to integrate to.
What I would want to, I made no changes. It wasn't accepted. It was bantered back and forth, and one of the obstacles I ran into was I presented the whole package to the dean, and he said, Heinz, what I need you to do is interview each of the chairs of engineering departments. So I went to electrical engineering and mechanical and civil. I went to every one of them, and I sat down and said, here's my proposal. Every one of them came back and said, this is a great idea. Where are you going to put it in the curriculum? I said, I don't know. I don't do curriculum. I don't know. And part of their question was, so what are you going to take out of the curriculum? I don't know. I don't do curriculum. So it waited, and I don't want to say it festered like a disease, but it waited and waited. Now there's more interaction happening now. But the kinds of things that I wanted to put in, again, were things, communication is probably one of the most important things. To be able to listen, there are two things: to be able to speak well, communicate, and present well. It's no longer death by PowerPoint. People don't want to see your PowerPoint slides. They want to know what you can teach them. And listening is so important. And we talk about these kinds of things when I'm teaching. I say, when you get into industry, if you come in and say, hey, look, I know it all, first of all, you're wrong. You will alienate yourself from your colleagues. But if you come in with a humility to say, can you teach me something? No, I'm facing a problem and I don't know what to do. Can you teach me something? People will really like you and help you. They'll really help you because they want to see you succeed. And then you are going to learn from them, people that have much more experience, much more wisdom, much more technical and non-technical smarts, just because of their, I'll say, survival for a long time. And if you pay attention to that, not only do they become friendly workers with you, because, gosh, she had the humility to ask me something. She wants to learn something so we can all succeed. That works very well. Those are not the kinds of skills that we're taught. So there are things like that. Simplifying presentations have to pop. You have to come in and say, okay, here's my presentation, this is what it is, here's the call to action. We are hoping we have, I guess, dusted it off. After my original, I'll say, run at having this as a project, how shall I put it? I grew weary of running into the wall. I said, I cannot face this anymore. And so it's being picked up again by some other people. There are other people who play now. Dr. Podoff is very keen to support it. The new chair of the Industrial Advisory Board, there are new people on the Industrial Advisory Board now too, and they are keen to see us make these changes. So my original proposal, sometimes it just takes a couple of tries. You don't always hit a home run the first time at that. So I'm fully supportive of it again. And one of the things that I am doing is I am running workshops for students, like on some of these skills, leadership skills, time management skills, communication skills. I'm running workshops for engineering students at Wayne State, not just chemical, but all engineering students. So there are some of those things filtering through for people to learn those skills. I'd love it. I would like very much to see it become part of the formal curriculum. Say, okay, now you're going to have a project planning course. Mm-hmm. You're going to have a presentation course, perhaps not like the one that you had, but presentations that really pop. And you got, it's almost like TED Talks, learn to give TED Talks.
Yeah, because the presentations that we would do, they just, it's kind of death by PowerPoint there. For QuantumQik Careers, your career planning business, where did you get the idea for that
from? In the mid-'80s, I read an article in the Chemical Engineer magazine, and it showed a thing of creating a career roadmap. Just a simple flow diagram that said, you started here, what might your next steps be? And I created one of those. Again, I'd only been in industry for maybe 3 or 4 years. I created one of those and I took it to my boss and said, Tim, was his name, can I talk to you about this career plan? And he pushed it back, literally, he just pushed it back across his desk to me and said, I can't promise you anything. I said, I don't want you to promise me anything. I just want to talk to you about it. And then he said, you need to go talk to my boss, the technical director. I went to him and he just about fell out of the chair. He was so happy. He said, now I can see where you can go. And I know, for example, in this position that you have on your map, this person's going to retire in 2 years. We need somebody there. They will probably move there, etc. And that became something. I carried that thinking with me. And then once I got through some of my managerial roles, once I got into some of those managerial roles, I started mentoring other people and saying, so let me coach you and connect you with people. You don't know what your next position might be. In fact, you don't even know what the roles are. But let me connect you with some people that I know and sit down with them and basically interview them. And I still do that. Gosh, I set up people today to talk to 3 people. What they do is set up a 10-minute meeting. And they say, this is who I am. You're elevator speech. I'm Heinz Plaumann, blah, blah. This is who I am. So they have a context. Tell me, how did you get into your role? Basically, their elevator speech. What do you like about it? What would you change about it? And who else should I talk to? That now gives you some understanding of what that role is. Whether you could find yourself into a role like that, whether that should go onto your roadmap or not. And once you ask, who else should I talk to? course, now you're tying into their network. All of a sudden, your network explodes.
Mm-hmm.
And that has proven so useful. So that's the kind of stuff that I do when I run workshops. I give people that thing. Initially, here's a roadmap. Let's talk about things you could possibly do. Do you have any idea what your passions are, your interests in life? There are documents that I send people to read and study up on those. But as long as you're on finding your passion and purpose in life, once you got that, create some options. And that becomes starting to fill in the next layer of the roadmap. To say, okay, here's some things I could do. And then I always tell people to think about some never do's. Think of things that you just would never do. I can give you two. One, I'm never going to work in the medical field. Not my passion, not my skill. Well, what's wrong with that? Nothing. Two of my kids do. Two of my daughters work in the medical field. I'm so happy for them. I'm so happy that they work there because I benefit from it. I'm never going to work in a bank. One of my other kids works in a bank. I'm so happy for her. Not my passion. So get into something that you're passionate about that you would almost do, even if you didn't get paid for it. Of course, you do have to use it. So that's the kind of coaching that I do. And mostly I connect people, and then I'll do resume reviews, because these days simpler is better. The first rule on a resume is it has to pop. People are going to only look at the top inch or so of your resume. If there's nothing up there that grabs them to read the rest, they won't. People are so busy, they're not sitting there reading your resume like reading a fun novel. They want to know that a resume is a business document. Top inch or two, that's it. So how do you make that pop? How do you make your elevator speech pop? Hey, you want to talk to me some more to do that. So those are the kind of things that I coach people with. And a lot of times people will come back to me and say, well, I got an interview. I spoke with a client today, and he said he's had a number of interviews over the last little while and hasn't got jobs yet. Right now is a very difficult time. End of the year, COVID-19, lockdowns, etc. So difficult to get jobs. Some of my clients have gotten jobs this year. Many of them have had interviews. Many companies, many of these are industrial positions. Many companies right now are saying early next year. Can't do it now. Can't do it now. It's end of the year. Budgets are where they are. So they just kind of want that down.
You had the idea once you made your career roadmap,
Yes,
and you kind of carried that through, and then you decided to start helping other students with it and career planning and all these skills that you saw that they didn't learn in school.
I'll backpedal for just a second. I had developed that reputation when I was still working in the industry. It was sort of the talk of the town. If you want to talk about career planning, go see Heinz.
And so you just kind of developed that reputation, like you said, and then QuantumQik Careers came out of it.
Yep.
Is your customer base mainly students?
No, I would say mainly not students, because students don't have a lot of money.
Oh, so then you coach like industry professionals on where they might want to go in their careers.
I coach, yes, I do that for sure. And I don't want to make it sound like it's a big money generator, but there is some money involved and there are some fees involved, but I do a lot of it free just to support people. The students, pretty much, they get the service free, and it's a matter of seeing them succeed. I've coached people, I've coached high school students looking to, where should I go to study? Mm-hmm. Should I go to college or should I go to trade school? And one, I'm thinking of a student, a high school student, he's studying to be a diesel mechanic now. Mm-hmm. It's a wonderful thing. Right now we are short of trade. I've been coaching a person that's a retiring minister from a church. The guy, I spoke with him over breakfast, and he said, I'm 66 years old. I want to know what to do next. And I said, well, can you do this? Can you do this? Can you teach? So again, and everything in between. Early professionals, young professionals, students, senior managers, senior professionals, university professors. I've coached some of them.
I've heard that it's difficult to get a role as a professor, but you got it through connections, right? But in terms of getting a job as a professor for someone who was following that track of like bachelor's, master's, PhD, wanting to go to academia, what are some tips that you'd recommend if someone like me were trying to become a professor? Because you didn't initially do it. You didn't initially do your PhD and master's wanting to get into academia, right?
No, I absolutely did not want to go into academia. I did not. I said, no, I want to go out there and work in the real world. I want to go work in the real world and do that. And I don't know why, because I had no industrial experience. Mm-hmm. But I just said, I want to take that instead of, again, I had already sensed from my environment at the university during my studies that the life of the professors, as I said, it's the cycle. Have an idea, get a grant, work the grant, publish the papers, get another grant. And I said, that's not quite my shtick. I just did not feel drawn to that.
But did you do research as a professor there?
No, I do no research at Wayne State. I teach and I do this administrative stuff, but I'm an adjunct professor. I'm not a full professor, right? I'm an adjunct professor, which means they give me that professor title, but I don't do any research. But there are other professors that do no research. There are many that have more administrative functions and things like that. Lots of people that do no research.
But you would still need a PhD for the most part, right, to be an adjunct or a regular professor?
As far as I can tell, yes.
How did you like that working there compared to working in industry?
I like very much teaching, and I like having the opportunity to coach students. Now there are enough areas, if I had to do research, I could do research. because I do a lot of technical consulting too, and I look and say, gosh, there are many, many areas where research can still help. But I would not want to give up what I do now, which is just adjuncting, teaching once in a while, doing this consulting, running workshops. For me, that is so rewarding and so much fun that I would not give that up to go back and have to create funding proposals for research. I would not want to do.
What, I guess, tips would you offer for students wanting to get their foot in the door to become professors after getting a PhD? And do you think, because what I had thought initially was that once you get a PhD, you're in such a niche field that it's very hard for you to find an open position, because you'd pretty much have to go anywhere in the world, whatever university has a position in that very specific department, that's where you would have to go, and you don't have those everywhere. So, I mean, what do you think about that?
It's an element, I think, that is pervasive everywhere, is to be flexible and never stop learning, to be curious and just learn. Again, like I said, be a learn-it-all. If you do that, even as a professor, as a young professor, to say, okay, I need to learn new things that I can make relevant in my proposals. And also, so that's one thing, is to be very curious and keep learning. The other one is to network like crazy. People go, what do you mean professors don't network? They all do. Every professor that I've spoken with, they have contacts at UCLA, they have contacts in Europe, they've got contacts all over the world. Contacts at Stanford, contacts on the East Coast and University of Boston, etc. So that networking is not specific just to industry or government labs. Everyone needs to know a lot of people, I would say. And for professors, that's great, because that's a way to get ideas to do joint collaborative work.
Yeah.
I give you an example. I'm still in contact. Dr. QuantumQik Careers, who is the chairman of chemical engineering until most recently. She moved to Australia in January of this year. I had a Zoom meeting with her last week just to touch base and see how she's doing. We talked a bit about research. We talked about some of their programs. I'm trying to align some contributors to a small called the Monograph, a book on alternative energy. And they've got some people at the University of New South Wales in Australia that work in hydrogen generation, storage, and then using hydrogen as a source of energy. So I'm connected with those people.
Going off of what you said about alternative energies, I remember you mentioned that you were in the middle of publishing a book, right? Or a textbook, or you had published some already on alternative energy. Can you expand a bit more on those?
Sure.
Right, you showed me that last time.
The publisher here at Greuter is a publisher in Berlin, in Germany. And they publish all kinds of stuff. They publish textbooks. But this is a series of books about green chemistry. And I am the joint editor with Dr. Mark Benvenuto. He is a professor at the University of Detroit Mercy, and there I am. And so this one happens to be green chemistry in government and industry. We've submitted all the chapters for green chemistry, water, for water treatment, water sourcing, water supply. The next one is alternative energy. So my task in doing that, in the water, I rounded up a whole host of authors from all over the world. I said, can you write us a short chapter for a book like this? And so, like I said, we got all the chapters together. The chapters are, I think they're all in Germany now for their review, and say, okay, we're going to publish it. Now I'm looking at people to do alternative energy. So I'm recruiting people from Carthage, as I said, in Australia on hydrogen as a source of energy storage, generation, etc. Nuclear plants, I'm in contact with some institutes in South Carolina, I think, on nuclear plants, fusion. I'm in contact with institutes in Canada on wind energy, on other sources of energy. So I'm piggybacking off of my other co-editor, because he was on that. There are a number of volumes. The one on water is volume 7. The one on energy is volume 8. Mark's been editing the volumes since volume 1. I think I wrote a chapter in volume 3. he came to me and said, hey, can you write a chapter on something? I said, I don't know. I wrote it jointly with a guy in Canada. So I wrote a chapter. Then he said, would you like to be co-editor with me? I said, sure.
When you say you're networking with experts to get them to write a chapter of your book, what exactly are they writing on? I don't know, making wind energy, solar energy, and so on? Or what specifically are you asking them to talk about on the subject matter?
Let me give you a couple of examples, perhaps over the water one that's to be published. We have in there's a local expert in the Detroit area named John Hartog. He has worked on Great Lakes water, supply, treatment, purity, et cetera, for decades. He's actually quite a renowned researcher at the University of Windsor, even though he lives on the American side. So he's writing one on Great Lakes water. There's another chapter being written by people from the Great Lakes Institute of something from the University of Windsor. Mike McKay and a group of people working together there that have said, look, we'll write you a chapter on, there was a big algae plume coming out of, I think, the Maumee River into Lake Erie, and they're researching that, so I've got them to do that. There's a group in Toronto at Ryerson University that wrote a chapter on green roofs. It's water supply. It's water coming onto it and it's green. It is required by law in Toronto, new construction must have green roof, or you pay some kind of a penalty to not have a green roof on new construction of buildings. And so they wrote me a chapter on that. We have a chapter from a professor at University of Michigan in Dearborn, and the chapter is about swimming in the desert. What does that mean? Well, it's about water supply in fairly arid states like Nevada and Arizona, where almost every other house has a swimming pool. I mean, they don't have enough water to water their cattle and water plants and stuff. It's a very dry area. But almost every other house has a swimming pool, and that's wasted water because it's treated with chemicals and can no longer be used as potable water. So he's written a chapter on that. We have a chapter on microplastics. We have a chapter on PFAS, the polyfluorinated materials. So things like that. So
when do you expect this alternative energy book to come out?
Once we get all of our chapters lined up, I sent an email today to recruit some more authors. So it should be up by the end of 2021, I hope. The water one will be first. That one will come out by the end of 2021.
Yeah.
The energy one probably end of 2022.
I wanted to ask you, moving forward, like what fields can chemical engineers work in, and where can you go as a graduate? And do you think that students should do a master's in the field, and just things like for after graduation?
Energy for sure. Water supply, food supply. I'd say biotech is very important too. One of the things that I would suggest is to make sure, a quote a friend of mine from the American Chemical Society, again, Bill Carroll, says, teach yourself the next big thing. What's the next big thing? We don't know yet. So pay attention, it's coming. 10 years ago, I'll tell the story perhaps this way. 10 years ago, the next big thing was apps on your phone. Our phones are full of apps. Our computer, everything's full of apps now. They're still being developed, but that's not the next big thing. 5 years ago, the next big thing may have been 3D printing. 3D printing is very common. You can buy a 3D printer. We can buy a 3D printer at Home Depot for about $400 and buy a resin and start making stuff. What's the next big thing for us going to be? We don't know yet. It's not here, so pay attention. That's why it's important to keep learning new things and look at it and say, what can I, as an engineer, learn to do where I'm going to apply my problem-solving skills, not my skills in kinetics or mass transfer, but my problem-solving skills. TLE, think like an engineer. Right? Think like an engineer.
Right.
And don't constrain yourself. I recall having someone in my office said, I want a job as a chemical engineer. I need to work in a refinery. And I said, nope, not true. Engineers can do just about anything. They can learn to do so many things. I've coached engineers who work in the plastics industry, working in the metal industry. One of your classmates is now becoming expert in inspecting welds on high-strength aluminum, flooring. I had a Zoom meeting. I had a call with her recently. I talked to Angabir. Angabir is working in a company that makes
battery electrolyte.
Yep. Soulbrain is the name of the company where he works. They make liquids for storage of energy. I talked. Your class was so much fun. You guys were just crazy. Dr. Plaumann, come and have ice cream. Dr. Plaumann, come and have a beer with us. You guys are terrible. It was wonderful. So the main thing there is to say, and you saw this in my career, there's no point that I say, I am an organic chemist.
Mm-hmm.
I would have tended to that if I'd gone into academics, because that was my formal training. That was my deep, deep expertise. Instead of that, I said, okay, I learned organic chemistry. Let me apply it to polymer chemistry called rubbers. I worked in the rubber industry. Let me apply it to production, becoming an engineer. Let me apply it to emulsion polymers. Let me apply it to polyurethanes. Let me apply it to soaps and surfactants and cleaning aids. Let me apply it to coaching people. And then it's a matter of just becoming flexible and say, okay, I don't want to say what's the biggest game in town, but what's the game in town? Just pay attention. And I think that's going to be a career plan to say, to be successful in a career and to have a good time doing it is to be flexible and keep learning and give a lot. Famous book by Adam Grant, Givers and Takers, or Give and Take, I think, Give and Take. It almost sounds ridiculous, but when you give, you actually get more back. Even if you're helping people, you get more back. It might not be money, but it's going to be a reward that comes back. So give and take is very important.
Right.
I've always touted Covey's book, 7 Habits. It's old, but it still works. 7 Habits are highly effective people.
Ahmed was reading one of those books, and he was telling me, he's like, Dr. Plaumann recommended this book, and it's really good. I forget what it was called. I think Covey was the last name.
Yeah, that would be the 7 Habits of highly effective people. The first one is to be proactive. First habit is to be proactive. Nothing happens unless you do something. So to start up and do something.
Oh, you know what? I was thinking of How to Win Friends and Influence People.
Dale Carnegie.
That was the one that I was reading. Yes.
Again, these things are so old. Like that was written in the 1930s, I think. So it's old, but we still don't get it. We still don't do it.
Nowadays, do you think it's necessary for students, especially in this industry, to go to do a master's and specialize in a specific field of chemical engineering? Or do you think that we can learn on the job and that, higher education is not really necessary after you have your bachelor's? Because like we talked earlier, that it really teaches you learn how to learn when you do engineering. It doesn't really constrain you to one specific field. So do you think it's necessary to move forward with your education, unless if you don't want to go into academia or anything?
My suggestion there is to know your environment, know the culture. If people there do well and move ahead, whatever move ahead means to you, without, I'll say, the paper, without the degree, then you don't need it. But you still need to be confident in showing that you're learning. The paper is a different thing. There's a discipline in going back to school and just say, well, look, I did this. Like I did my master's degree in chemical engineering. I gave up a lot of sleep to do that. But it doesn't matter. It maybe aged me more than I should have, but it doesn't matter. That's not the point. The point is I learned a lot of new things and I continued learning to learn. And that's the key. So if your environment, people with bachelor's degrees, people without even bachelor's degrees, with like technology degrees, associate degrees, do well in what you think is doing well. How do you define success? If you think they can do well without, I'll say, the paper, then that's what you need. But you need to do what your environment requires it. And I know that, gosh, I worked in a German company where a doctorate was the ticket to get anywhere. And that's just an artifact of German history. But I know lots of people with master's degrees, with bachelor's degrees that do very well. Now, if your employer will support you going back to school and doing, say, a master's degree or an MBA, it's something to take advantage. Of course, you need to weigh the time, effort, etc. I mean, many people have other commitments around family, around other hobbies, around other things like you do podcasts. You have things like that to say, well, can I balance the time to get it done right? So you should always do the best that you can, whatever endeavors you undertake.
Overall, like any tips you'd want to give to students who are stuck in their careers, don't really know what they want to do?
The most important thing, they should contact me and talk to me after they. What I would suggest to students is, first of all, ask questions and be respectful. I almost go back to what I used to call the big three, which in our culture, be on time. It's respectful, the right thing to do. It's your reputation. He's always on time. She's never on time. It becomes your reputation. And part of that, I'm going to come to in a second why that's important. The second thing is always do what you say you're going to do when you say you're going to do it. Neha, I'll get you this report on Tuesdays. Tuesday, where's your report? The third one is manage their expectation, because I'll say, well, I'm going to get you this report on Tuesday. I can't do it. Is next Friday okay? If you let them know, you won't disappoint them. Disappointment, being late, not doing what you say you're going to do, not delivering on time, that's employment. That's an emotional experience that people don't forget. People
Right.
will forget what you said and they'll forget what you did, but they're not going to forget how you made them feel. Angela Maya made that comment, but it's so true.
Yeah.
People are going to remember how you made them feel. And if you hurt them by being late, by being disrespectful, by being dishonest, by not being trustworthy, they're not going to forget them. That's hard to overcome. So when you look at those things and say, okay, as a student, as a young person in industry, you can build a lot of that by gaining respect from people, asking them questions. That's tremendously respectful to say, I don't know everything. I'm a learn-it-all, not a know-it-all.
Mm-hmm.
Teach me something. People will love to teach you, and you'll gain a ton of respect from them.
And so with that, and thank you so much for joining me today. We had a really great talk and I learned a lot, and I'm very excited to share this episode.
Very good. Thank you so much.
And that's a wrap. Thanks for tuning into today's episode, and we'll see you next time.